So who's feeling radical today? I hope you are, because our lesson is radically long again. It doesn't look it, but I'm going to have to do a splice, okay? And it's not going to be radically easy, kind of like before. I don't know that it's more difficult today. We're just really building on what we did before. But we're dealing with radicals, remember? And radicals in math are some term that's being rooted, okay? Whether it's square rooted, cube rooted, or in Espanol, cuatro or cinco rooted, whatever rooted it is being rooted. And so we're going to build on what we've done. We've looked at radicals, we've simplified radicals. Well, today we're going to be multiplying radicals. And so get your pens, your pencils, not your pens, especially your green pens. Stinking Micaiah, no green pens. Get your pencils, get your paper, and get your calculators too, because remember, we can use our calculators in this little more difficult of a chapter all the way through. Okay, we're going to be multiplying radicals today, and in so doing I want to remind you of a rule that we considered from the opposite perspective yesterday. And that rule is whenever you have some term and like say two numbers or variables or a combo of numbers and variables multiplied to each other, but they're being rooted to the nth power, whether that's a square or a cube or whatever, that's all that means, that you can write those separately if you choose to do so. You can write it as x to the nth power times y to the nth power, but under separate root symbols. Well, what we're going to do is look at terms today that are under separate root symbols, but we're going to combine them back into one, and you can work those back and forth to your advantage, okay, to help you. And we saw yesterday how that can help you. We're going to see today how taking the disjointed ones and conjoining them can be a benefit to you. For instance, if we have the square root of 2 times the square root of 6, and those are understood to be square roots because there's no number there, and when there's no number it's understood to be a 2, it's a square root. Those are not perfect squares, are they? That one's broken down in its simplest form. That one we can break down to 3 and 2, but we can't take a perfect square out of 2, we can't take a perfect square out of 6. But here's the benefit of joining those together under one big happy square rooted marital umbrella. We're going to put 2, okay, this is what we have, but we're going to break this one down into its two main factors, which are what? Of 6, 2 and 3. And so instead of 6, we're going to write 2 and 3. And remember, I showed you that's the longer way. Well, sometimes you need to do the longer way to help you out. You don't have to, but I think sometimes it can be a benefit. Break them down into their prime factors. And here's the reason for doing that. Remember, if I get 2 of the same under a square root symbol, I can pull one of those numbers out and cancel them both out. And here's the math reason why. Because 2 times 2 is 4. And what's the square root of 4? It's 2. But you can almost take a shortcut and say, well, under a square root, if I see 2 of them, I just cross out the 2, and I pull out one of those 2's to the outside. And so that's what I'm going to do. I'm going to pull out 1, 2, and cross out those 2. And so simplified, the square root of 2 times the square root of 6 is 2 square root of 3. And as I said yesterday, isn't that cool? No, many of you are saying, I hate life. Oh well, get over it. You're going to enjoy it, I promise you, by the time it's done. Okay, so that one's pretty simple though. That's not too hard, right? Number 2. Let's move quickly because we'll have more that we have to do too. Okay, so number 2. Number 2. Negative 2 times the square root of 18 times 5 square root of 50. Now, what I can and what I must do on these in multiplying radicals is I can multiply what's on the outside together, and I can put under one happy square root umbrella what's found on the inside, except squish them together. But if they're on the outside, keep them on the outside. If they're on the inside for now, keep them on the inside. So, here's what we're going to do. Negative 2 times 5 is what? Negative 10. And so I'm going to keep that on the outside. But I've combined the two. Now, in breaking down each one of these and putting them under one big happy marital square root umbrella, I want to ask myself, if I can, do I see any perfect squares that are factors of 18 and any perfect squares that are factors of 50? And for 18, is there a perfect square factor of 18? Yes, that number is 9, but the other number needed to multiply together to get me to 18 is 2. And so I'm going to write as factors 9 times 2 for 18. The reason I'm not breaking that down further is because I know since it's a perfect square, I can just do what I want to do and move that one to the outside. Now for the number 50, that's also under a square root symbol, and they're being multiplied, so I can join them, even though they're disjointed, I can join what's inside the square root symbols together. Do I have a perfect square of 50, or a perfect square that is a factor of 50? Yes, I do. And what's that number? 25. And what do I need times 25 to get me to 50? Simply 2. So 25 times 2. Okay? Now, watch this. I know the square root of 9 is 3, right? And so I'm going to cross out the square root of 9, and I'm just going to move it as a as a 3 to the outside. Okay, and I need to keep the multiplication sign. That's what I was trying to figure. How do I write this? Keep the multiplication sign times 3, but I got rid of that square root of 9. All right, 25. I know the square root of 25, and that's 5. I'm going to move that out here. Cross that out. The square root of 25 is 5. Okay? And so what I have is 5 times 3 times negative 10. Okay? What's 5 times 3? Let's go ahead and do some simplification here before we finish. What's 5 times 3? That's 15. What is 15 times negative 10? Well, that's not that hard because it's just 15, a negative sign, and since it's a 10, I just add a 0. Okay? So negative 150. Now, square root of what's still underneath my square root symbol? 2 times 2. What's 2 times 2? That's 4. Wait a minute. What's the square root of 4? That's 2. Or I could have seen it in this way, since it's a square root and I have 2, under a square root I have 2 2's, I could cross them both out and move 1 2 out. Or if it makes more sense to me, I can just multiply them together, get 4, and say, well, wait a minute, I know the square root of 4. That's a perfect square. That's 2. And so I can move out here times 2. I have, guys, no square root symbol left. That's wonderful when it works out that way. And so what I have now is this, 2 times negative 150. I can use my calculator, but I can also use my God-given one, and you can too, to do that simply. What's 2 times negative 15? Well, 2 times 15 is 30. But since it's a negative, put a negative in front, and there's a 0. So put a 0 at the end. What's my answer? Negative 300. Now isn't that really, really, really neat? That I can break all of that down, and every now and then I'll get to where I don't even have a square root, cube root, or quattro root, or cinco root in Espanol left. And that's really neat. That's what I want to do whenever I can do that. Okay, let's toss in some variables. We haven't done that today yet. We did that some yesterday. But let's toss in some variables. All right, and here's what I'm going to do. I have the square root of 6ab times the square root of 2bc. Now, I need to keep it all, remember, I can combine separated ones all together. That's what I'm going to do. I need to keep it all under a big happy marital square root umbrella. And I can multiply numbers times each other under that umbrella. What's 6 times 2? Okay, that's 12, but I'm going to do it differently though. I'm going to break 6 down into its prime factors, 3 times 2, and I'm going to keep that 2 right there. And if you don't already, you're going to see why I'm doing it that way. Keep it in prime factored form. In this case, I think it makes it simpler. Okay? Just an A times an A. All right? Instead of doing what we did yesterday, times B squared. B squared. I can do it that way. Okay? And say 2 out here is square root of of b squared. 2 divided by 2 is just 1b that I can move out here. Let me show you a different way that might make even more sense to you. Okay, and I don't think this will be any more confusing. I may be wrong about that. I don't think it will, but I think it may help some of you, and so I'm going to try it this way. Instead, I'm just going to keep it in its factored form, b times b. Okay, prime factored form, and then times just a single c. Let me elongate, so all that's under a square root. Now, remember, when I have duplicates of anything, like a 2 and a 2, I can cross those out and just move one of them to the outside. Guys, I can do the same thing with variables. If it makes more sense to put it written out in prime form and say when it's under the square root, whenever I get 2 of anything, I can just cross them both out and move one of them out here. You can do it that way if you want, and that's perfectly fine. There's no issue there. If you prefer to write it b squared like we did yesterday, and say when I'm taking the square root, I just divide whatever that number is by the number of the roots, 2 divided by 2, and however many whole ones are, go out there. However many leftovers as a remainder there are, stays under there. Either way works exactly the same. So, hey, dime a dozen. Whatever you prefer, do it that way. But here's what I have on the outside. I have it as b2. Of course, we would write it as 2b, the number first. And so I have 2b on the outside now, right? What do I still have underneath the umbrella? Square root of 3, and in terms of variables, a and c. They can't come out because they're only to the first power, and that square root is to the second power. And it has to at least be to the same power before I can pull that out as a single one. I don't have that many. I don't have 2 of those as exponents in a or c, so they stay underneath the square root marriage umbrella. Okay, so for number 4, cube root of 2 pretty good sized numbers. 225 times the cube root of 315. Okay, I'm going to put all of these under a big, happy, marital cube, not square, but cube root umbrella. But I'm going to use my calculator to help me break some of these down. So here we go. You ready to rock and roll, guys and gals? Let's do it then. Okay, I'm just going to do some guesstimates, all right? 225. I see a 25 on the end. I'm going to hope and pray that a 25 gets me... Oh, well, if I punch it in right, maybe. I'm going to hope and pray that a 25 gets me somewhere evenly. Let's try that. Good. All right, so we have 25 and 9, right? Divided by 25. 225 can break down into 2 factors of 25 times 9. Okay, now I'm going to do 315. Remember, if they're separate, my rule is I can put them under one single root, in this case a cube root, and so that's what I'm going to do. All right, let me get it here where we can all see. So now we have 315. Okay, I see a 15 at the end of the number. I'm going to hope and pray and divide by a good sized number to speed up this process of prime factoring down. Divided by 15. It's a beautiful thing, isn't it, when it comes out to be an even number. Okay, 15 and 21. 15 and 21 are 2 factors of 315. Now, watch me and what I do. All I'm going to do is just keep breaking these down until I get to all the prime factors, okay, of this number. What are my prime factors of 25? Now that's a perfect square, but we're not dealing with squares. Perfect square, we're dealing with what we need is perfect cubes. So perfect squares don't matter with cubes. Well, what are the 2 prime factors of 25? Those are 5 and 5. 5 times 5. 2 prime factors of 9. 3 times 3. 2 prime factors of 15. 5 and 3. And lastly, but certainly not leastly, I don't think that's a word, 2 prime factors of 21. 7 and 3. Okay. Now you might be looking at that and say, what a mess. I just want to go back where I started. I just want to close my math book, go home and take a nap and eat some bonbons. Okay, we can't do that and still solve the problem. So what we're going to have to do is, the reason we've done this, guys, kind of like squares. Remember, under squares, if you have two of the same term, whether it's a number or a variable, you can take one of those to the outside. Okay, one of those to the out. You can do the same thing with cubes, but it has to fit that number on the outside, meaning you have to have three of the same number, or three when we get to them of the same letter, to bring just one of those to the outside. Do I have three appearances of any number under here? Yes. There's a 5, there's a 5, there's a 5. I can cross out all three of those 5s and pull out one 5 to the outside of the cubed root symbol. Do I have any other numbers that appear more than, that appear 3 times? Yes, and in truth, I started to say, I have 3's that appear more than 3, but I can't do any more unless it's an even, divisible number of 3. Okay? And now 3 of them, look, 1, 2, 3, I can pull 1, 3, multiply, don't forget, that's the sign of all this. These two will be multiplied to each other just like they were multiplied on the inside. So I had 3 5s, so I pulled out 1 5. I had 3 3s, so I pulled out 1 3. But look what I have left over. Still 1 7 and 1 3. There's nothing I can do with those. But now I'll multiply what I find on the outside. 3 times 5, which is 15. Cubed root of 7 times 3, because I cannot break them down any further. And what do I have there? 7 times 3 is 21. So guys, my final answer right there, my final answer, get out of the way so you can see it a little bit better, is 15 cubed roots of 21. All right, that's numbers 1 through 4. I'm going to take just a couple minutes. I'm going to rewrite 5 through, 8. But I'll try to make it as quick as possible, yet as understandable also. And we'll finish that up. Have you guys forgiven me? I hope so, because we need to finish this math work. Let's have hard feelings at each other later. Now, we will. We'll get through it. And I know you guys are doing a good job, okay? And I have every confidence. I just know I can tell right now with you, even though we haven't talked about it, I can tell right now that yesterday it was very, very difficult. You're thinking it's never going to work. And then I can already tell today it is starting to click more. Okay, and it's going to click more as the chapter goes on. I always tell you, just trust me. Don't give up on me, okay? Stay with me all the way through, and you will be just fine. In fact, I believe you will excel. So we're going to move on with number 5. We could break all these down into their absolute prime factors, or we could take a little bit of a shortcut. And we could ask ourselves, do I see any perfect squares? Okay, as I combine these two under one marital umbrella, per my rule, do I see any perfect squares in the number 50? Yes, I do, as a multiple of 50, and that's the number 25. What times 25, though, gets me to 50? 25 times 2. And so I'm going to use 25 and 2 because I know I can easily pull that 25 out of there because I know the square root of that number. Do I know a square root of 32? A perfect square that is a factor is what I'm trying to spit out. All these different terms, it makes it difficult to express at times. Of 32, yeah, 4. How about 4 and 8? But let me think about this though. Is there a larger perfect square than 4? I can do it that way, it's just going to take more time. Is there a larger perfect square that's a factor of 32 than just the number 4? And yes, there is. It's the number 16. 16, and what times 16 gets me to 32? And that is the number 2. Okay, 16 times 2 gets me to 32. 25 times 2 gets me to 50. I can put them all into one because the rules of math tell me that I can do so, even though they're initially separated. I did that on purpose because 25 can be pulled out. The square root of 25 is what? 5. And so I can just move that to the outside of the parentheses and cross it out. The square root of 16 is what? 4. That's why I chose that term, right? And you did too. And so I can pull that out here. And remember, it's multiplied times 4. Okay? And now I'm not going to make the same mistake I did earlier and say, okay, 2 times 2 and put it together and then do another step in the end. Remember my other rule. If it's a square root, there's a 2 understood right here, and I have 2 numbers that are the same, what can I do with those 2 numbers? I can cross them out and pull one out to the outside. And guess what? When I do that, there's no square root symbol left. All I have left is some multiplied numbers together. Again, if I wanted to, I could have kept 2 times 2 under there, but in the end I needed to ask myself, well, wait a minute. 4, the square root of 4, 4 is a perfect square. What's the square root of 4? 2. And so you see I just did a step ahead of time to save me a step in the end. So what is 2 times 4? 2 times 4 is 8. What is 8 times 5? That is 40. And so guys, again, my answer is just the number 40. I have no square root symbol left and certainly no terms under 1. I love it when it works out that way. Sometimes it does, sometimes it doesn't. Now in these cases, I have the cube root of each one of these terms. And what I'm going to do is take the 2 separated terms, and as I've been doing throughout this lesson, I'm going to put them under one beautiful union of marital bliss, these cubed roots. But I'm going to break them down as I do so. Now this time I'm not going to my exponents. I want to remind you what we did yesterday. There are 2 or 3 ways to do each one of these. I think this is probably the easier of the 2 ways for the exponents, is my personal opinion. I'll let you choose. I showed you the one way at the start of this lesson. I'll show you the way again that we did yesterday right now. But what I am going to do with all my numbers themselves, I'm going to make them prime factorization. 2 times 2, okay? And then over here, let's just break them down into 2 multiples that'll get us down quickly. And that's going to be 8 and 4. 8 times 4 is 32. Now you can use other ones and you're still going to get to the eventual spot, okay? So don't sweat it if you want to go a little different route. That's okay. But I have 2 times 2 and 8 times 4. And now I have to multiply together my variables. What's x to the 2nd power times x to the 1st power? It's x to the 3rd power because I add them when multiplying. Y to the 5th times y to the 1st. I add them. 5 plus 1 is y to the 6th. And I just have a z. Okay, a z to the 1st. Alright, now what I need to do, guys, is break down these numbers into the most prime form I possibly can. So I'm going to keep 2 times 2, and I'm going to speed up the process a little bit. 8 prime factored is what? I could have 4 and 2, but I still have a 4, and that would break down to how many more 2's? 2. So 8 is how many 2's in prime form? 3. 2 times 2 times 2. Now again, I could take an extra step. I just don't really want to do that, and partly because I'm running out of space. So for my 8, I'm going to have, instead of 4 times 2, which is true, I'm going to have 2 times 2 times 2. Go ahead and break down the 4 into 2 2's. And then I have the number 4, which breaks down into how many 2's? That's right. 2 more 2's. That's a bunch of 2's. And then I have x to the 3rd, y to the 6th, x to the 3rd, y to the 6th, and then z just to the 1st power. Okay, now watch this. Every time I have 3 2's, what can I do with one of those 2's? Pull it to the outside. 1, 2, 3. Cross them out. Pull out a 2. 1, 2, 3. 3 2's. Times, because they're all being multiplied together, times a 2. Okay? And so as I rewrite down here, what's 2 times 2? I now have the number 4 on the outside, cubed, not square, but cubed root. What do I have left? I can't do anything with the 2 that's left, so I have to keep it under there because it's all underneath the cubed root. Now watch, I have x to the 3rd power. I could write it out x times x times x, and because I have 3, I know to pull 1x to the outside, or I can do it this way that I showed you yesterday. Since it's the cubed root is being taken of all these terms, I can divide x cubed by that root power on the outside, which is 3. What's x to the 3rd divided by 3? 3 divided by 3 is 1, or x to the 1st power. And so I can move that x to the 3rd, however many times it goes in wholly, okay, into the root. I can move it that many to the outside, which is just a single x. Now, y to the 6th. I can divide that 6 power by 3. What's 6 divided by 3? That's y squared. And since it goes into evenly twice, however many times it goes evenly, I can pull it out to that same amount on the outside of the root symbol, which in this case would be y squared, because 6 divided by the root of 3 is 2. And then lastly, I have a z, and it's just to the 1st power, which is less to the rooted power of 3, so I can't do anything with that. That has to remain underneath. So I'm going to rewrite these in proper form now. Number first, which is going to be 4, then letters in alphabetical order, x, and just to the 1st power, y squared, now times, understood, the cubed root of what's left? 2z. Okay, so what do you think? Is that registering a little bit better than yesterday? I have every confidence that it is, and you guys are just brilliant anyway. But it's like anything, and I'm the same way. Everybody is, guys. The more you do it, the more comfortable you get, the faster, the more efficient you are, and really, truthfully, the more you'll begin to enjoy it. So let's try 7a. We're going to do something a little bit different here, a little bit different. We're going to distribute square roots and cubed roots, okay? Actually, we're not doing cubes here, but we could do that and roots to other powers too. We're just going to do square roots. That's not bad for this lesson, and we're going to distribute. And here's the way that works. I have a square root of 5 times, in parentheses, square root of 3 minus 2. Now, the way that I do this, just like anything, I just multiply that times that times that. And look, remember my rule. If I have 2 separate rooted terms and I multiply them together, I can put those under the same umbrella. So that's exactly what I'm going to do. Square root of 5 times the square root of 3 is the square root of 5 times 3, which is what? 15. But both of them remain under a square root symbol. It's just they were disjoined, but now they're conjoined under one square root symbol. Now, this one's the one that's a little trickier. When I have the square root times just a whole number, I don't put that number underneath the square root sign. I keep it outside of it. And since that's a whole number, I just write the whole number minus 2. But joined or now multiplied to the square root of 5. And because there is no perfect square anywhere in, even if it's a multiple of 15, I can't break that down further. And because 5 is a prime factor already of itself, I can't break that down further. Technically, I could make that square root of 5 times the square root of 3, but again, there's no perfect root in there, so nothing's going to come out, so I just have to re-multiply them together and leave it there. So I'm going to save the step and not do it. That's my final answer, guys, right there. The square root of 15 minus 2 times the square root of 5, okay? And since these are different roots, because they're being added and subtracted now that I've distributed, because they're different roots or different bases, square root of 15, square root of 5, there's nothing else that I can do with those. I'm done. All right, now I'm going to do the same thing with 7b, only here I have a number outside, 2 square root of 6 times the square root of 15, and also in parentheses with the square root of 15 is minus 3 square root of 10. What do? I'm just distributing this whole term, every bit of it, times it. And look, whenever you have a square root of 15, there's no number in front. Actually, there is a number in front, and it's understood like it is many times, to be a 1. It's just an invisible one, all right? So what I have in terms of the numbers outside of the square root symbols, I multiply those together. What's 2 times 1? 2 times 1 is 2. Now, don't forget, I multiply what's inside the square root and put them under 1. What's 6 times 15? You can use a calculator if you want, but I hope you can do that one in your head. I think you can. That's 90. So I have 2 times the square root of 90. But don't forget to do the second one also. Keep your sign, okay, minus, and then I don't have to worry about negatives anymore for right now. Multiply what's on the outside of the square root symbols times each other. What's 2 times 3? I've already put the negative, so I'm not worried about that. What's 2 times 3? That's 6 times the square root of. Multiply what's under the square roots times each other. What is 6 times 10? And 6 times 10 is 60. All right, and there we go. So, what is it that we're going to do from this point? Well, we're going to break things down into prime factors, and we're going to do that with each one. If you don't care, guys, I'm going to erase this on the left side, and if you do, even though I love you, if you do care, that is, even though I love you, I'm still going to erase anyway, but still love you right there, whether you love me back or not. So I'm going to erase this just so I have more room to work and I don't get so crunched that you can't see it very well, or two, skip an important step and then it not make sense just because I didn't have space. So here's what I have. I'm going to rewrite. This is on number 7, and understood is actually 7b. Okay, but I have left 2 square root of 90 minus 6 square root of 60. Okay, what I'm going to do here is I'm going to break these down. What's underneath the square root? Okay, I'm going to break those down into smaller terms. I see very obviously 2 factors of 90 are 9 and 10. Okay, I'm going to use 9 and I'm going to use 10. And in part I want to use 9 because I know what 9 is and you do too. That's a perfect square. And so I'm going to keep that way because I can easily pull something to the outside from that. Minus 6 square roots of, what is it that we want to pick here? 6 and 10, okay. One just hit me though. How about this one? 6 and 10, no perfect square. How about 4 and 15? Aha, there we go. And the reason I like 4 and 15 is because 4 is a perfect square. Makes it easy to move to the outside. Okay, so let's simplify. I have 2. Okay, well here, let me pause right there. I want to do this just a little bit differently. Save some space in the step. I can simplify square root of 9, right? Because what is the square root of 9? That is 3. And so I can put times 3 out here and cross out the 9. Okay, and in the case of right here, what's the square root of 4? I know that. That is 2. And so I can multiply negative 6 times 2. I know that's a little sloppy, but that's my step that I'm going to do. So what's 3 times 2? That's 6. Okay, I'm left with the square root of 10. I could break that down into the prime factors of 2 and 5, but there's no perfect square that's a factor of 10, so it's going to remain that. All right, what is 2? What is 2 times negative 6? Negative 12. All right, I'm left with 15, square root of 15 times the square root of 15. Now, I could break that down into 5 and 3, kind of like 5 and 2 over here, but there's no perfect square that's a factor of 15. So it appears, guys, as if that's going to be my final answer. What do you think about that? That's it. That is the final answer. 6 square root of 10 minus 12 square root of 15. Okay, let's do one more. You have that down. If not, pause and finish writing because I'm going to erase this, okay? And so I have plenty of room for our grand finale. It's going to be our firework that is a fountain, an explosion, whistling, and just perfection in every respect, all in one. So number 8, find the area of a triangle with sides of 6 feet, 8 feet, and 10 feet. Wait a minute, why are we doing basically geometry here all of a sudden when we're dealing with radicals? Well, it's geometry with radicals. And so we're taking a practical thing and we're putting it into application. Find the area of a triangle with sides of 6 feet, 8 feet, and 10 feet. I want you to look up here before we do this problem. We need 2 important formulas. Make sure you write these down. You can use these now as we solve this problem. You can use them on your homework for your quizzes, and you can also use it on your tests, or a test singular. So please write down both of these formulas. Okay, we're going to need to be able to find a side. I'll show you how in just a minute. But the formula for the area of a triangle is the square roots of, and that 2 doesn't apply to that, okay, that's for the one above it. But A equals, or area of a triangle equals the square root of a side, okay, of S a side, times S that side, minus A in parentheses, open parentheses, that side minus B, okay, or the second side, close parentheses, and then S minus C, which is the third side, close parentheses. But before we can use this formula, we have to know what S is. The way that you find S in the area of a triangle, I'm going to write this formula up here. S equals, and I have it there, S equals one side of the triangle plus the second side of a triangle plus the third side of a 3 angles, okay? All 3 angles added together and then divided by 2. Okay? So, what are my 3 sides? So I can find S that I then can use to plug into my formula to find out, which is a radical of itself, to find out what the area of the triangle is. S equals one side, which is 6 feet, plus a second side, which is 8 feet, plus a third side, which is 10 feet, all divided by 2. Okay. What is, we can do these in our head, simple. What is 6 plus 8? 6 plus 8 is 14. What is 14 plus 10? That is 24. All over what number? 2. Okay, so what is my S in the formula? What's 24 divided by 2? It is simply 12. Okay. Now that I have my S, I want to use my A, or my area formula of a triangle. Okay? And the area formula for a triangle, I'm going to rewrite the whole thing just so we get a little more familiar with it, is the square root. It's a radical, all of itself. Square root of S times in parentheses, S minus one side, A, times, in parentheses also, S minus the second angle, the length of it, the size, B, close parentheses, just like the first one, open parentheses a third time, that same number S minus the third angle, the length of it in the triangle, C. Okay, well, let's put some numbers to all this madness. A equals then, the square root, what's S? Guys, that S, time and time again in this formula, in this problem, is 12. So every time I see S, I'm going to plug in 12, which is there, which is to start the first parentheses, minus, what's A, or one of my lengths? 6. Close parentheses. Open parentheses, S, that's 12 yet again, minus, what's B, my next angle, the length? 8. Close parentheses, open parentheses, S, which is, again, 12, minus my third and final angle, which is 10 feet in length, close parentheses. Okay, order of operations. First things first, simplify what's in the parentheses. Keep your 12. What's 12 minus 6? 6. What is 12 minus 8? 4. What is 12 minus 10? 2. Guys, from this point, what I'm going to do is I'm going to break this down into prime factored form. Okay, keep breaking these down more. 12. What are two factors of 12 to get me closer to prime numbers? How about 4 and 3? 4 times 3. What are two prime factors of 6? 3 and 2. What are two prime factors of 4? 2 and 2. And all that we have left is 2. Okay, still with me? Don't give up on me quite yet, okay? We're not done. Now there's one more that we can break down just a little bit further, and that's the number 4. What are the two prime factors of 4? 2 and 2. Okay? Then we have 3 times 3, and then we have 2 times 2, and then yet again 2 times 2. Now remember, since it's a square root understood, whenever a number appears twice, every time it appears twice, I can pull it out a single time to the outside of the square root symbol. Here's 2 twice, so I can cross that out and pull out a 2. Let me just do that down here since I'm running out of space, okay? I'm going to pull out a 2. And that's outside, no square root symbol understood. I don't have it over it again, notice. Alright? Those are 3s. How many? 2 of them. If I have 2 3s under a square root or a root to the second power, I can cross out the 2 3s and use one of them outside of the square root symbol. I have 2 2s. Guess what? I can cross those 2 out and keep your sign, no multiplication throughout for each one of these, and I can pull out a single 2 from one of those 2s. Since it's a square root and I have 2 more 2s, I can pull out a single 2 from that one. And now look, I have no square root symbol left after all that hard, ridiculous work I've done. And that's the beauty of math, simplifying things, coming out with full, true answers, and it can go no further than that. What is 2 times 3? That's 6. What's 6 times 2? That's 12. What's 12 times 2? That's 24. Guys, the area of a triangle, given the measurements that we were supplied, using these wonderful, beautiful, mathematical, found in design, the design of nature formulas that God has given us, or area equals, of that triangle, 24, what units? Feet. Okay? But don't forget, and I'm teaching pre-algebra this right now, and you guys have learned it and used it a few times by now. If you're finding the area of anything, the units are what? Feet squared. Its volume, it would be units cubed. But every time you're doing area, it's the unit and squared. So the area of that triangle is 24 feet squared. Voila! That's it, guys. I'm proud of you. Thanks so much for working at this, and thanks for not giving up on me. I know it hasn't been. I know it's still probably not easy at this point. For some of you it may be. For most, and maybe even all, maybe not. But keep working at these because I just want you to think about this. Now, in all seriousness, today compared to yesterday, is there any comparison? Yesterday you were lost. Yesterday you were confused. Yesterday you just wanted to die and go to heaven. Okay? Well, today you may still want to go to heaven, but you don't want to die right now. And I'm confident that you're not lost and you're not as confused. It's starting to make more sense. So just stay with me, okay? Do this each day, and we're going to get better at it. And by the end, we're going to be very good at it and perhaps maybe even master it by the time we're done. All right, thanks for the work, guys.